This tutorial is going to demonstrate how to do a one-sample Wilcoxon test on R. A one-sampled Wilcoxon signed rank test is used to assess whether the median of the sample is equal to a known standard or theoretical value. This is a non-parametric equivalent of a one-sample t-test, so it's particularly recommended in a situation where the data are not normally distributed. And this means that the data does not fall into a bell-shaped curve, as demonstrated by the graph on the right. When doing a Wilcoxon test, the sample size should be at least 6, otherwise it may struggle to become significant. The first thing that you need to do is install and load the following packages. To install a package on R, you just type install.packages and in brackets and quotation marks the package name. And then to load it, you can just type library and then in brackets the package name. Remember that you only have to install a package on R once, but each time you want to use it, you need to load it in by using the library function. For this tutorial, we are going to use the mice data from the data.rem package that we have just downloaded. So this dataset includes the weight of 10 different mice. We can view the dataset on R by using the view function, remembering that view has a capital V. And here is what the data looks like, where the name is all of the different mice and their weights. The assumptions of a one-sample Wilcoxon test are that data are distributed symmetrically around the median. And you can check this by creating a histogram using the HISTOGRAM function, like so. Note that in this code we have changed the option bins to 4, as you can see here. And this is because our sample size is only 10, and the default on R is bins equals 30, so you'll probably run into an error. And here is the histogram that this code produced. As you can see, the weight data is approximately symmetrical. Remember that this graph does not have to be perfect. So now we can run a Wilcoxon test, and we can do this to answer the question, does the median weight of the mice significantly differ from 25 grams? And this is a two-tailed question, as we have not specified whether we think the weight will be higher or lower. You can compute the Wilcoxon test by using the Wilcoxon test function. And the general formula is Wilcoxon test, and then in brackets the dependent variable, which in our case is weight, a tilde and 1, and then the mu, which is a theoretical median. So for our example, this would be 25, because we want to see whether our weights significantly differ from 25. So here is our formula for the data set we are using. And here are the results. As you can see, the median weight significantly differs from 25, and this is indicated by our p-value, which is less than 0.05, but please check if your supervisor uses a different cutoff point. We can also calculate the effect sizes on R using the Wilcox effect size function, like so. And here are our results. So as you can see, there is a large effect size, which is indicated in this column here. And finally, this is the full script of the tutorial for you to have a go with yourself.